you want to solve equations, here is how. Read them with their operations, do it now. Then undo them every time by directions in this rhyme. Do the opposite, that's what the rules allow. If you read minus, then to solve them you must add. If you say plus, you must subtract or you'll be sad. Multiply will get undone by dividing everyone, and divide gets multiplied or answers bad. Oh, equations must stay balanced to be true. What you do to one side, you must do to two. And to solve for the unknown, you must get it all alone, using every single trick you know to do.
Welcome everyone to our first segment of our Algebra 1 review on solving linear equations. So we had that little song. I like to start with some little goofy song sometimes. So we're going to be looking at solving linear equations, different ones, very simple ones up to very more complex ones in this review. This starts off Algebra 2 as we start to look into just remembering what we learned in Algebra 1. So before I do that, let's go to a quick little cartoon. Here's a Far Side cartoon. That's Midvale School for the Gifted. And the door says pull. So apparently this boy is supposed to be gifted, but he can't read the sign that says pull. Alright, well let's get into our first page here on solving equations, just one-step equations. So these are the properties of equality, and the little song even kind of talked about that, where you have to keep your equation balanced to be true, it said. So the properties of equality means that both sides need to remain equal the entire time that you are solving the equation. And so to do that, you need to do whatever you do to one side, you do the equal thing, the exact same thing to the other side as well. It's what we call the golden rule of algebra. So like you can see here, as we're looking at addition property or subtraction property or multiplication or division property, whatever they're doing there in red on one side, they're doing the same thing in red on the other side to keep the equation balanced. So if they add 4 to the left side, they're going to have 4 to the right side. Or if they multiply the left side by 3, they're going to multiply the right side by 3 just to keep everything balanced. And then they do the operation to do that. So you can see as they see in numbers there, then you can see the algebra. Here's the actually kind of equation they see. So they're going to add 5 on this one. They're going to add 5 here. Well, when we do that, it will undo the operation you see. So you see subtraction, but you're really going to add. And that's what another thing that video said. You see addition, but you're really going to subtract. You do the opposite operation always to undo. And you're going to see that through every equation that you do through Algebra 2. Even in the most complex equations, such as like logarithm equations or radical equations, you're going to do the same thing. You're going to undo by doing the opposite. So you have to first figure out, okay, what is the opposite? And obviously right here we have addition and subtraction. Those are opposites of each other. Multiplication and division, those are opposites of each other as well. And so they're undoing them by doing the opposite. So if you see subtraction, they're adding to undo here. And now then they perform the operation here to give you 8. Same thing as you can see down here, we're going to be seeing z over 3, so we're going to multiply by 3. It's the opposite, z divided by 3. So you multiply, so you see division, you're going to multiply. Or in this one, you see multiplication, 2 times w, you're going to divide the opposite to solve that, to undo it. So 2 over 2 would give you 1 here, that undoes that, leaves you your w by itself. So your variable needs to be all alone. You need to isolate or make it all alone there to be able to get your answer solved. And then here's a couple more examples you can just look at. You can pause the video and just take a look at these examples here. Example 1. Okay, if you want to go back and look at that example 1, you can, or on your paper. But we're going to go on to this practice here, and I'm only going to do the highlighted ones, and then the rest of them you need to want to pause the video and then finish the rest of these from 5 through 12. But let's just go through 1 through 4 together. Number 1, we see subtraction, so we're going to do the opposite. We're going to add the 6. So we're going to add 6 to both sides, the left side and the right side of that equal sign. Here's where you can undo the 6's. That leaves the h by itself, and then perform the operation over here, 2 plus 6, to give us our answer of h equals 8. So now the h is by itself. We know the answer is solved. Number 2, we see j over 3. That means it's divided by 3. J divided by 3. Every time you see a fraction bar, think of the division operation. And so we got j divided by 3. We want to multiply to undo this. We see division, so we're going to do the opposite and multiply. I'm going to put parentheses around each side and put a 3 on the outside to show I'm going to multiply each side by 3. And here's where the 3's here would undo each other. They would actually could cross each other out, leaving the j by itself. And then over here you perform the operation. 9 times 3 gives us 27, so j equals 27. On this one, number 3, we see addition, so the opposite would be subtraction. We want to subtract by the number 8 to remove that from the k. We don't want to add 9 on this one because the k is our variable. The k is what we need to solve for. So we need to undo what's with that k on this side, the left side. So subtract 8 to undo the 8. And so now we would cancel these out. These would undo each other, and you perform the operation over here. Negative 9 minus 8. You have, basically two negatives. When you would add those, when you see the same sign, you would add them and they become a bigger negative. So you add 9 and 8, it's 17, but it's a bigger negative, negative 17 for k. And then number 4, here you see multiplication. Now you may not see it, but actually whenever you see a number next to a letter, we know it's going to be multiplying there. That means multiplication, 4 times m. You may not see a symbol there to show you multiplication, but you need to know when it's right next to something. It could be right in front of a parenthesis, in fact. But if it's right in front of a letter here, number in front of a letter means multiply. So we want to see multiply. We need to divide by 4 to undo this. And so 4 over 4 can cross out. That could become a 1, leaving us with just 1m on this side equal to the operation here is 12 divided by 4, which would be 3. So m equals 3. All right, so go ahead and pause the video now and finish up 5 through 12 on your own. Okay, the next section takes us into more of the evaluating to determine whether a solution, actually determining whether a number 4x is a solution to an equation, and that's what we're going to see here. You can go ahead and pause and take a look at these two examples, but we're going to try one of these here in just a second. So again, here's example 2. Again, you can pause and take a look at example 2, and you can see what you're doing is you're plugging in a number. It says solve the equation and check your solution. And so these ones actually you are going to be not plugging in. That was the last one. That was back here. Here's you're plugging the number in. So you have 1. You're going to plug that in, as you can see here in red, and see does it equal. Does one side equal the other side? Yeah, 4 equals 4. Or this one you plug in that number 2, but negative 11 doesn't equal 10. You can see the not equal, the slashes through the equal sign. And so it's not a solution on that one. Here's where we're going to see it's a multi-step. It's more than just one step. So we're still going to do all the things we learned in the last part and just do more than one step. So this time you're seeing you're going to add 3 first, and then you're going to divide by 4 to find your solution. So we'll talk about those a little bit more as we get into that. But you go ahead and just take a look at this. I paused the video, just look through this and make sure you understand what's happening with solving these equations. Okay, so in this practice, 1 through 3, it says determine whether x equals 1 or x equals 3 is a solution to the equation. So we're going to do just problem 1, and I'll have you try 2 and 3 on your own. So as we look at problem 1, we're going to start with a here. X equals negative 1. So we're going to plug in negative 1 where we see the x. Now this one only has one x in the problem. You can see down here on 3 there's 2 x's, so we'd have to plug it in on both places. So when we plug this negative 1 into this x, remember this is multiplying 5 times x, it's now going to be 5 times negative 1 as we plug that in. And then the plus 7 equals the 2. So we want to perform the operations over here, just like order of operations. So we want to multiply first, and then we'll add 7. So if I say 5 times negative 1, that's going to give me negative 5. And then I'm going to actually subtract here because they're different signs. Take 5 away from 7. That does give me positive 2. So that works out. This is equal. 2 does equal 2. So yes, that is a solution. All right, let's go on to B, which is x equals 3. So we're going to plug in 3 this time. So it'll be 5 times 3. And we'll work that out first, then add the 7 and see if it equals 2. Well, 5 times 3 we know is 15, and 15 plus 7 is 22. 22 does not equal 2, so we put the not equals to sign there and say, no, this is not a solution. They're not equal to each other. So go ahead and pause the video now. Do the same thing for 2 and 3. Do the A and the B. Each one, the -1 and the 3, plug those in separately. So actually really have 4 more problems really here to do. Okay, so on this little section here, solve the equation, check your solution. We're going to do just 4 of these, and then the rest of them I want you to do on your own. So some of these are actually back to just a single one. So these first 4, or first 3 right here are just really kind of ones like we did before, just a one-step. But when we get into number 7, we may start to get into some 2-steps or just some maybe different, situations. Number 7, let's take a look at this one now. It's got a fraction, and don't be alarmed when you see a fraction. Just know that's going to take, maybe 2 steps to do this. You have it, the bottom number. Remember, whenever you see a fraction, you think of division. This is like 5 divided by 6. So when you see division, you can always undo that with multiplying. So what we can want to do first here is actually multiply by 6. Multiply equally to both sides here by a 6. That gets rid of our fraction. So when we do that, we'll put parentheses around this side and put parentheses around the -15. Put the 6 on the outside. That will cancel out the 6's, and now it leaves the -5 in front of t. So now it's just -5t equal to, perform the operation here, -15 times 6 is -90. And then we can just see, okay, now we have -5 in front of t, which is a multiplying situation. Now we divide to undo that. Divide by -5. And that would cancel this out, leaving us with just t, and then -90 divided by -5. Remember your integer rules, negative divided by negative is always positive. So this will be a positive answer, and 5 goes into 90 18 times. So it's a positive 18 for that one. You got to be careful on these little negative signs and the integer rules here that you don't make a simple mistake. Look at number 8. This one's also an interesting one. It seems like it's just a one-step equation. Like all you need to do is just subtract 46, because there's your x. 46 is with the x, and that's a positive. So it means to undo that, you're going to subtract 46 to both sides, which you will do. And that would cancel this out, and you think, okay, that leaves x by itself over here, and you perform this operation, 81 minus 46. That's 35. Problem is that your x is a negative x. So you have a negative sign in front of x. You just can't say x is 35. Negative x equals 35, and you don't want to leave your answer with a negative variable. So to undo the negative sign, this is like -1 times x. You can undo that just by multiplying by -1, multiplying or even dividing. Since it's a 1, it really doesn't matter which operation you do. I usually like just multiplying by the -1. That will just change the signs. It will still leave me with a 1x, but negative times negative here will be a positive x, and over here it will change the sign as well to a -35. In fact, a little shortcut you can just think of is if you have negative x equals positive 35, then just switch both signs on both sides. Positive x will equal -35. And so there's our answer. So x is solved, and it equals -35. Let's come down and do 14, 15 down here. We have variables here on both sides. You can see that's what we have here on 13, variables on both sides. We have a parenthesis, which would be a distributive property, okay, where you distribute. So the first thing on 14 is just to rewrite the 2c plus 5. That's going to be rewritten. We're not going to do anything with that just yet. We have to distribute 3 into this, which means multiplying 3 times both c and -8. You got to do it to both of those. So 3 times c would be 3c, and then 3 times -8 is -24. So that becomes a 3c minus 24 now. So now when you have variables on both sides, you want to get the variables all to one side, the numbers to the other side. And here's a little trick that I usually do. I look at which variable is smaller out of the 2. Or, in this case, 2 is smaller than 3. And so what I want to do is I want to move the 2 to this side where the 3 is. So that way I subtract 2c from both sides. If I didn't do that, I could subtract 3c, but then I'd be left with this situation that we had on number 8 with a negative variable. And it just allows us not to have to worry about that step. So if we just always do it this way, where we're trying to get it to be a positive variable first, by subtracting 2c from both sides, that will cancel out the c's here, undoes them, leaves me just the 5 now. And then 3 minus 2 is a positive 1c. So it allows me now to have a positive variable. I don't have to worry about this situation. So now I have 5 on the left side, and I have c minus 24 on the right side of this equal sign. And now I just got to undo this. I see the subtraction, so I want to add 24. So I'm going to add the 24 to both sides. That cancels them here. 5 and 24 make 29. So our answer for C is 29. So you might be thinking, okay, what is the operations? Do I add or subtract first? Do I multiply or divide first? The kind of the steps that you always want to take here, as they start to build and get bigger and bigger. And this number 15, we're going to see kind of all of them in this one. This is going to be the longest one. I'll start off by saying first you need to undo any parentheses. If you see parentheses where there's a distributive property like we have on 15, we're going to need to do that first. So that's what we got to do first here. So we have the 18m, but then I got to distribute the 3 into both of these, making 6m next. And then 3 times 8 is going to give me 24, and then it will equal the 0 on the other side of the equal sign. The next step, you want to make sure that each of your sides is as simplified as possible. So if there's any like terms to combine on each side like we have here, so you have 18m and 6m, we want to put those two together. So we want to combine these like terms. That's the next thing to look for and do. You may not always have that. In fact, we haven't seen that yet. So, but we do see it here, and we want to combine these together to give you 18 plus 6 is 24. So we'll see 24m plus the 24 is equal to 0. So we combine these two m terms into this 24m term here now. Now the next thing you want to do is, you want to look for, maybe you might have a situation where you still have variables on both sides. Then you want to get your variables to one side by adding or subtracting. So we're doing that first. We're doing the undoing the addition and subtraction. So we're moving our variables and noticing we have to subtract to do that, or sometimes you might have to add to do that. And then moving the numbers to the other side, again with adding or subtracting. The last step we do is multiplying or dividing. In fact, we didn't have that on this one. I think we will have it here. So let's take a look. We have to do the adding or subtracting step. So that means we need to move the 24 to the other side. We're going to subtract 24 from both sides. And that will leave me my 24m here, 0, negative 24, and now I can do my dividing step, 24 times m here. I'm going to divide both sides by 24. That's the last thing we're doing is the multiplying and the dividing on these bigger ones. And now we see we just have to do this operation here. Negative 24 over 24 is negative 1. So now we have m by itself, and it equals negative 1. So we have to get all the way down to where we're solving for m and getting it by itself. What does 1m equal? That's always our goal is. Or what does 1c equal? 1c equals 29 on this last problem. All right, so go ahead and pause the video and then work through these other problems to solve them. Some of these are going to be easy, but that gets a little harder as you get a little further down. Okay, still on that same page, 16 to 21. There's a couple here I wanted to try with you together, and then I'll let you try these other 3 by yourself, 18, 19, and 21. So with 18, you see this kind of big fraction here. Again, the first thing we want to see here is that we have the x on the top of this fraction, and it's all being divided by 5. So really on this particular problem, the best thing to do is to get rid of this fraction first. Whenever we see fractions, that's what we like to do first, is just get rid of the fractions. So I'm going to get rid of this by undoing. This is dividing by 5, so I'm going to multiply by 5. Remember, the opposite operation of division is multiplication. So we put parentheses around both sides here, and then just put the 5 on the outside to show we're multiplying both sides by 5. And that would cancel the 5s out, leaving us just with this numerator part, 8 minus the 3x. And so that leaves us with that, and it's going to equal 5 times x over here, which is just 5x. Okay, so now we do have variables on both sides. We certainly want to put, since there's only 5x over here, we want to put this over here, and it will let us have a positive variable. So I'm going to add 3x to both sides, right? I see subtraction, so the opposite of that would be to add. So I'm going to add that to both sides, giving us, 8 on this side. These will cancel out. They'll undo each other. So 8 over here, 8x on the other side. And so 8 equals 8x. Well, now we would divide by the 8 in front of that x there. And 8 divided by 8 is just 1, so we know x equals 1 for 18. All right, going over here 19, we see parentheses, but what we don't see is anything in front of those parentheses to distribute. There's actually no distributive property going on here. They're just, for some reason, they decided to put them in parentheses. They didn't have to. They only have to when there's something multiply, like if we had a 2 in front of this to distribute, but we don't. So in this case, we want to do just combining like terms on the side, because we have 2 terms that have r's, and we have a 6 and a negative 1. We can put those together also. So we're going to put these r's together, 8r, and this will become a positive 4r. Now, one thing we want to realize is that there's a plus sign here in front of this one. If that was a minus, we would definitely have to distribute the negative and change both those signs. So be careful about that. So we do have a 8r, and this will be a positive 4r. So that gives us 12r with combining those. And then we're going to combine the 6 with the negative 1. 6 minus 1 is just a 5, so it's plus 5 now. And then the equals 14 at the end. And now we're just down to a 2-step equation. So first we get the 5 to the other side, so subtract 5. We see addition, so we're going to do subtraction. Minus 5, that cancels them here. Perform the operation over here. 14 minus 5 is 9. So now it's 12r equals 9. And we'll divide by 12. Right? We see this is multiplication, so we're going to use division to solve. So we divide by 12, and what we get over here now is r by itself. And this is over a fraction. This is 9/12. That does not become a nice, neat whole number. In fact, this is going to stay a fraction, but what we want to do is we want to simplify that fraction of 9/12. We want to realize that 3 can go into both 9 and 12, and so the answer for this will be 3/4. 3 goes into 9 3 times, 3 goes into 12 4 times. You always want to make sure your fractions are in simplest form for your answer. And then number 21, this one maybe seemed like the hardest one out of all these. We see a whole bunch of fractions in this one. And like I said, that when we see fractions, we want to get rid of the fractions right away. And to do it on this one, we have so many fractions in this, we want to multiply the entire equation by the LCD. That is the lowest common or least common denominator. So out of these here, we want to look at 2 and 10. Now the LCD, even though it says least or lowest, doesn't mean the smallest number. In fact, it would not be 2, but it could be 10. So you got to look at the bigger number out of these. Can the smaller number go into the bigger number? Because you only have 2's and 10's here. So since 2 can go into 10, we can use 10 as the LCD. If that wasn't the case, well then we want to look at the next biggest number that both of these two numbers can go into. So obviously 10 can go into itself, but 2 can also go into 10. That's why we can use 10 as the LCD. So now what we need to do is multiply this entire equation. I'll put parentheses around the entire thing, multiply it by 10. So this first term times 10. Well, 2 will cancel out. 2 goes into 10 5 times, which means there's still 5 left over to multiply this numerator by. So that's going to be 1 times 5 with an x. So that's a 5x for the first term now. See how that made it no longer a fraction. And then on this one, since this one has a 10, 10 goes into 10 one time, they will cancel each other out. We can cancel that 10 out, and now it's just a -3 for the second term. Then we have our equal sign for the middle. Again, we have another 2 here, so 2 goes into 10 5 times. There's still 5 left over to multiply this numerator by, so 5 times 5 times an x would be 25x for the next term. And then since 10 again is on the bottom, we'll cancel out that 10, and then this one will just be plus 7. There's nothing left to multiply because the entire 10's gone. Nothing left to multiply that numerator by, so it's just plus 7. So that made it a whole lot easier to work with. Now we have variables on both sides. We want to definitely move the 5x over here to keep our variables positive. So I'm going to subtract 5x. Even though I don't see a plus sign in front of this one, I know that it's not a minus, it's positive. So the opposite of positive would be negative. So subtract 5x from both sides. That cancels them here, gives me Now negative 3x on this side, 25 minus 5 is 20, x plus the 7. And now we want to move the 7 to the other side. So I'm going to subtract 7. There I do see the plus sign. So subtract 7, I'm going to get negative 10 over here. Remember, these are going to be a bigger negative. And so I'm going to get negative 10 is equal to 20x. And then divide both sides by the 20, because that's with the x there. Divide both sides by the 20. And so that's going to give me a fraction again, negative 10 over 20. What we could do is just cross out those zeros, and now it's negative 1 over 2. We definitely, again, want to simplify our fraction. So it's going to be a fraction of 1/2. X is going to equal a negative 1/2. It is negative because it's negative over positive. And this fraction 10 over 20 would simplify to a 1/2. 10 goes into both of those. So 10 goes into itself once, 10 goes into 20 2 times, or you could just think of cross out those two corresponding zeros. Now you can see the 1/2. Alright, so go ahead and pause the video, finish up 16, 17, and 20 then on your own. Okay, I'm going to take a quick little short break here for a joke of the day. So here's our joke. Why did the painting go to jail? Why did the painting go to jail? It was framed. Because it was framed. Oh. Alright, moving on to our next part, which is literal equations, rewriting literal equations. What a literal equation is, you can read this through. What a literal equation is basically an equation that has more than one variable, and so you see more than one variable in these equations. Sometimes you see 2, sometimes you see 3, and it's going to say solve for one of those variables. So that means that you're not going to get a specific number for an answer. As you can see on these examples here, the answer for y, it says solve the equation for y, is not just a number, but it's actually an expression. So the answer to a literal equation is always just going to be an expression. And that's what's different about these. You're still going to use all the rules and all the undoing rules and everything we learned before. The only difference is you're not getting a number as an answer. You're getting an expression as an answer. Y is equal to an expression. You can see here's a different expression. Y is equal to that expression. So you can go and look through these examples. You'll see some of them in the problems that we're going to do. Let's jump in and try on a few now. Okay, so it says solve the literal equation for y, and we're solving for y on all of these. So let's take a look at number 2 first. And we'll do some of these here together. We'll do them together, and then you'll do some of these also on your own. So 4x minus 2y. So it's nice they highlighted the y in blue on my screen. On your paper, it might be not highlighted, or still probably all in black. But you can see it here on the screen that it's highlighted. And so we want to get that by itself, which means we need to move this 4x to the other side. So when we're going to, don't see a plus sign, but we know it's positive 4x, so we're going to have to do the opposite and subtract 4x. Positive 4x, negative 4x, got to be the opposite. And over here we got 16 minus 4x. These are not like terms, so we can't put this together. It's not going to make like a 12x or anything. So you be careful and don't put these numbers together here because these are not like terms. So now this undoes it here. You have a negative 2y on this side, and it's equal to a negative 4x plus 16. Now I always like putting the variables first, the numbers after that. So I'm putting the negative 4x first. Then still to solve for y, we know our next step would be to divide by negative 2. Divide by what's in front of our y here. So I'm dividing by negative 2, and I'm going to do that to all the terms. I have 3 terms here in this equation. I want to divide it equally to each term. So you might think, whatever you do to one side, do the same thing to the other side. And I'm just kind of splitting it up here. I'm doing it to the first part and to the second part of this other side. It makes it a little easier to understand instead of putting the whole thing maybe all underneath negative 2. So now this would cancel each other out here. This would undo it, leave me with y by itself. And now I have y equals, over here we have a couple things to do, a couple operations. Negative 4 over negative 2, we'd want to simplify that. And the 16 over negative 2, we'd want to simplify that. So let's take a look at what this would look like. It's y equals 2x. The reason why I get 2 here is because negative 4 divided by negative 2 is positive 2. 2 negatives are going to make it positive when we divide. 4 divided by 2 is 2. This one's negative because I have a positive over negative, and 16 divided by 2 is 8, so it's negative 8. So there's our answer for y. There's the expression that it equals. Remember, we're getting expressions here for answers, not just numbers. Okay, look at number 4. First thing I got to do is subtract the 2x, bring 2x to the other side. So that would cancel each other out. Remember, we're not going to put these numbers together. This is going to make an expression. So we're going to see 3y is equal to negative 2x. Put that first, then plus 6. I got to put a plus there. Even though I don't see the plus 6, I'm going to connect it with a plus or a minus symbol. It's not negative, so I don't put negative 6. It's positive, so I'm going to put plus 6. And now the next operation would be to undo this 3 by dividing by 3, just like we did there on the 2. So divide everything here by 3. That would cancel it out. And now we have a y equals, and we have, again, two operations we got to look at to work through. Negative 2 over 3, 6 over 3. Let's take a look at what this answer is going to be. So y equals negative 2/3 x. So on this one, 2/3, I can't simplify anymore. I can't make that into a whole number. I can't reduce the fraction. It's already reduced. That stays kind of the way it is. But then this one, 6 over 3 becomes 2. 6 divided by 3 can become a plus 2. So there's our expression that y equals. All right, the next one, I'm going to skip number 7 and then go on to number 9. So number 9 here, we see y on both sides. This one's going to be a little more challenging. First thing we're going to do is get these, since we're solving for y, we want to get those on the same side. We need to move this 3y to the other side. So I'm going to subtract 3y from both sides. And so that's going to cancel it from this side, leaves you just with a negative 8x. On the other side, we have two terms, and we can't put anything together. These are not like terms. They don't even end the same, because this is a yz, and that's just a y. So we can't put these numbers together. So we're going to have to leave it separate. So I have 4yz minus a 3y equal to negative 8x. Now what we need to do is we need to what we call factor out the variable that's in common here. So we see y is in common with both of these. We can take it out. So I can take this out, put this what's left in a parenthesis, and so it'll look like this. Y now can be outside. I highlight that in blue, and what's left would be the 4z from the first term, and this is the minus 3 from the second part. And so if I was to distribute y back into here, I would just get back to this. So now what I'm allowed to do is I have y times this, we call a binomial with the two terms, 4z minus 3. I can then divide both sides by this binomial, and that would give me my answer. So if I divide both sides by what I need to get rid of, because I'm trying to get y by itself, that would cancel out. The binomial can cancel with this binomial, because they're exactly the same thing. And then this would be our answer here. We don't have to simplify anything. We can just say y equals that. Y equals the negative 8x over this 4z minus 3. And there's my answer. Let's go on to 12 here. We see y also in two places, but it's in this big fraction. We've seen a big fraction before. The first thing we want to do, like I said, is always get rid of the fraction. So I need to multiply both sides by the denominator. Multiply by the y. And so when I do that, I'm going to multiply, put the parentheses around both sides, multiply by y. That would undo this y down here, leaving me with just my numerator, 5 plus y on this side. And over here I have a 3 with an x and a y attached to it. It doesn't matter what order I put the y first. I could have put the x, then the y. It didn't really matter. So what I need to do now, again, I have the variable y in two places. They're on opposite sides. Let's get this y over to the other side where the other y is. So let's subtract y from both sides. And so that's going to leave me just with 5 on this side, because those will undo each other. So I have the 3xy or 3yx minus the y. And again, we have the same situation where I have y in both terms. I can factor out the y and then put what's left in a parenthesis. So factor out this y here, and what's left from the first term is the 3 and the x, and what's left from the other one is just a negative 1. There's nothing left really, but there still would be a 1 there. We can't just say there's nothing. So you got to think of, there really is a 1 in front of this y, so that's still what's left, because if I was to multiply back, y times negative 1 would be just negative y. And again, we can do the same thing like we did up here, divide by this binomial. So my answer would be the 5 over that binomial. I'm just going to write the answer here as y is equal to 5 over this 3x minus 1, because we can divide both sides by that. All right, if I come back to number 7, let's go through this one and then we'll be done. So here you can see we just have y in one place, so we want to first just bring the 6 to the other side, so we're going to add 6 to both sides, and so that's going to give me that 2 with the xy. It's equal to 8x, put the x first, then plus the 6. And so on this one, we want to get y by itself, so we need to divide by 2x on this one. So we want to divide both sides by 2x to get rid of what's not y, get y by itself. So divide over here by 2x, divide also this here by, I mean, we can divide the whole thing, I suppose, by 2x. Maybe that might be the best thing since x is down here, because if I was to do it simply, I would maybe get something then over 2x here. So this one you might want to just do the whole thing divided by the 2x, and that would be fine. So if we did that, that's going to cancel out here. We're going to get y now is equal to, so we'll say y is equal to, the only thing here is that we want to simplify the numbers. So since 2 can go into 8 and 2 can go into 6, we want to reduce these numbers. And we want to say, okay, this 2 goes into 8 4 times, so this is going to be a 4x. And 2 goes into 6 3 times, so this is going to be a plus 3, and then it's all over an x. And that's what we would want to do there to get it into that form. The only other way we could have done this maybe is, we could have distributed that to both of them. There's another way you could write this, actually. If I were to do it by each x, I would say, okay, the x's could cancel from this one, so I would just be a 4 on that one plus 3 over x. So either way on this one would be fine. So sometimes they want one answer, sometimes they want the other, and either answer is correct. All right, so that concludes our first session here on the Algebra 1 review with the solvent equations. I'll see you on the next session.